It's a pleasant day to everyone, especially to our Professor Sir Jibayabay and fellow students. I am Vivi Bintalan from DSGD 1C, a group team Delulu presenter. On behalf of our team Delulu, we're having a group discussion or reporting which we will tackle about the introduction to manufacturing processes, including the mechanical design, app design, common flows of connection, wood, casting, form, molding processes, and lastly, the selection processes and types and examples. We also applying the learning goals, which are the understanding, knowing each processes design, and gaining knowledge. And Ruby Bintolan, I am the first presenter. So what is the design for manufacturing? Is a practice which are done to make design easy to manufacture. So design for manufacturability. So what is design for manufacturability? Is a design approach that consider the manufacturing process to design a product. It involves selecting the appropriate manufacturing processes for the product. There are 4 major factors in manufacturing. 1. Practically, as it focuses on design products that are easy to manufacture, assemble, and maintain. This involves considering factors such as availability of materials, standardization of components, ease of assembly, and compatibility with existing manufacturing process. 2. Time. It's aimed to minimize the time required for the manufacturing processes. This includes reducing the number of manufacturing steps, simplifying the procedures, optimizing production cycles. Cost. It's focusing on minimizing production costs without compromising product quality. This involves design products that requires fewer materials, reducing waste during the manufacturing, and optimizing production. Layouts to maximize efficiency. Quality. It ensures that the final product meets or exceeds customer expectation. It involves design products with built-in quality features, considering potential manufacturing defects or issues during the design phase, and the implementing quality control measures throughout the manufacturing processes. The 4 importance of the processes in mechanical design. Processes in mechanical design are utmost important as they ensure efficiency, optimize design, mitigate risks, and facilitate collaboration and communication, assure quality and optimize cost, promote standardization, and enable effective documents. The first processes in mechanical design is function. So what is function? In mechanical design, encompasses selecting appropriate manufacturing processes, planning the steps required for production, optimizing the chosen processes for improved efficiency and quality, ensuring product quality through the quality of assurance measures in analyzing costs for the cost-effective manufacturing and considerations sustainability aspects. Second, material is an aspect of mechanical design as it directly impacts the performance and reliability of a product. The choice of materials should be based on true understanding their properties, how they interact with the intended operating condition. Geometry is used to define the shape, size, and position of various components. It provides the mathematical presentation of the physical objects involved in the design, allowing the engineers to analyze and manipulate them effectively. It also helps in visualizing and understanding the relationship between the different parts, enabling designers to optimize their design for performance and manufacturability. Process is a term. Process refers to a series of steps or activities that undertaken to create and develop, refine a mechanical product or system. It compasses various stages from the conceptualization, analyze to detailed design, prototyping, testing, and manufacturing. The second I will tackle is about the mechanical properties. So what is the mechanical properties? Is the materials to have excellent mechanical properties. The studies of materials undergoing mechanical loading is very important for products in terms of reliability and durability. There are 12 types of mechanical properties. Ductility and brittleness. Tautness. Endurance limit. Damping. Thermal properties. Thermal conductivity. Specific heat. Glass liquid transition. Wear. Corrosion. Why do we need to know or study about the design process in mechanical design in engineering? Is because in mechanical design processes, it helps you or a company create the products or components that perform as expected and meet customer expectation. And what design engineer should know or should incorporate? 1. Design and manufacturing are interrelated in all mass production products. 2. Design a complex geometry solution defining out that is not practically and economically feasible to manufacture. That is common problem with this connection between the design and manufacturing. Last, the design engineer should understand the process too. 1. To make the suitable selection, production, or prototyping. To make sure that there are no excessive costs or wastage. And last, for smooth and flow of production development, avoid issues.
My name is Emerisa Van der Ricaldo, and my topic is about common processes in materials and media processing. So, what is common processes in materials and media processing? This encompasses a wide range of industrial and scientific processes used to manipulate and transform various substances and media for different purposes. So, these are some common processes in materials and media processing. First is casting. This used to create complex shapes by pouring a molten materials into mold. Next is machining. It involves removing material from a workpiece to achieve the desired shape using cutting tools. Next is extrusion. This means pushing a materials through a die to create objects with a consistent cross-sectional profile like pipes and tubing. The next is injection molding. Common plastics manufacturing where molten plastic is injected into a mold to form a various products. Then we have sintering, often used in powder metallurgy to compact and form objects by heating without melting. The next is lithography. This means a key process in semiconductor manufacturing. It involves transferring a pattern into a substrate like silicon wafers. Then we have printing. Digital and offset printing for media production and 3D printing for manufacturing objects. Then we have coating, applying a thin layer of material to the surface of an object to provide protection or desired properties. Then we have welding. Common na kayo sa atong welding no kay kuan makita namin nato bisag asa like sa mga buildings, sa mga kumpanya nga kanang maghimo sila og kanang mga materials nga need pag-combine mo na siyang joining two or more materials together by melting their edges and fuzzing them. So photo kong giingon nga makita nato sa building kay di ba kanang mga kanang kabilya like ug ato na silang i-combine kay dapat weldingon din na sila aron masumpay sila. The next is heat treatment, altering the properties of materials through controlled heating and cooling. So the next topic is about design approaches for process selection. So what is design process for process selection? The goal is to choose the most suitable method for making a product by balancing these factors to meet specific requirements and limitations, similar to selecting the right tool for a task. We have material properties. Consider the specific properties of the materials involved, such as strength, durability, conductivity, or resistance to certain factors like heat or chemicals. Select a process that aligns with the material's characteristic. Next, we have the cost analysis. So for this part, we should evaluate the costs associated with different processes, including initial setup, operating cost, and maintenance for the process that balances the cost effectiveness with quality.
Preparing the NA element and how reporting the process flow of a connecting rod. Raw material preparation is the first step. The process begins with raw materials in the form of metal billets. These billets typically consist of steel or other suitable materials that are chosen for their strength and durability. Next step is the forming and forging. The raw billets are heated then subjected to forging process. Forging involves shaping and heated billets into the desired connecting rod shape. This process helps align the end-grain structure of the metal, improving its strength and integrity. Next, machining. After forging, the connecting rod undergoes precision machining. This step involves cutting, shaping, and drilling to achieve the necessary dimensions and tolerances. Machining ensures that the connecting rod meets precise specifications. Next, heat treatment. Heat treatment is a critical step in enhancing the material properties of the connecting rod. This involves heating the rod to a specific temperature and then cooling it in a controlled manner. Heat treatment helps improve the rod's strength, hardness, and resistance to wear. Finishing. Once the heat treatment is complete, the connecting rod undergoes further finishing process. This may include grinding and polishing to achieve a smooth and precise surface finish. Surface finish is important for reducing friction and ensuring proper lubrication of the engine. Next, assembly with other parts. The connecting rod is then assembled with other engine components. It is a crucial link between the piston and the crankshaft in the internal combustion engine. The precise assembly is essential to ensure smooth engine operation. Next, using fastener. Connecting rods are often joined with other engine components using fasteners such as bolts and or nuts. The fasteners are tightened to specific torque values to ensure a secure and reliable connection. Last, final assembly. The final assembly of the engine involves putting all components together, including the connecting rod, into the engine block. This step also includes installing additional components like pistons, cylinders, and crankshaft to complete the assembly.
Hi, my name is Mitzi M. Atun.
Casting processes. Casting is a manufacturing process where molten material is poured into a mold to create a solid object. Common casting processes include sand casting, die casting, investment casting, and continuous casting. First, sand casting. In sand casting, a mold is created using sand as the casting material. It's a versatile and cost-effective method for producing a wide range of metal and alloy parts. So sand casting is like making a sand castle, but instead of fun, you create metal objects. You make a sand mold with the shape you want, pour in molten metal or alloy, and when it cools, you have your final product. It's a versatile and cost-effective way to make various metal parts. Second is die casting. Die casting involves using a metal mold to produce precise, high-quality components. It's commonly used for manufacturing parts with complex shapes and fine details, often with non-ferrous metals like aluminum and zinc. So die casting is like using a metal cookie cutter to make precise and strong metal parts for things like toys, tools, and cars. It's perfect for creating detailed components. Third is investment casting, also known as precision casting or last wax casting. This method is used for producing intricate and highly detailed parts. It involves creating a wax pattern, covering it in ceramic material, smelting out the wax, and then pouring the molten metal into the ceramic mold. Fourth is continuous casting. Continuous casting is typically used for producing long, continuous shapes like bars, rods, or pipes. Molten metal is continuously poured into a mold, solidifying as it moves through the casting process. So, continuous casting is a method to create long metal shapes like bars, rods, or pipes efficiently, making it useful in construction and industry for mass production. It's like making an unending string of metal. These casting processes are selected based on factors like the type of material, the complexity of the part, production volume, and the desired level of detail and precision.
Good day everyone, I am Shirley Aniskal and I'm going to talk about forming process. Forming process is a manufacturing method that involves shaping and transforming a material into a desired shape or configuration. This also can be done through various techniques such as bending, forging, casting, rolling, extrusion, or stamping that depends on the material and the desired of your end product. Forming process also are widely used in industries like metalworking, plastics, ceramics, and many more to create components or products with specific geometries and properties. To create a shape or configure, we have forming processes, and I believe we discussed these previous members. So first technique to form a shape or configure is number one is casting. So you need pouring. Casting is pouring metal into the mold. Second, forging. Metal is heated and desired shape is given by pressure. Extrusion, forcing metal to dies. Stamping, cold working process with the use of dies. Embossing and coining, metal is stretched. And the last one is spinning, which is high-speed lathe machine is used.
Good evening viewers, I'm here to report molding. What is molding? Molding is one of the 5 processes involved in rubber and plastic manufacturing, alongside casting, forming, machining, and additive manufacturing. Though they share some similarities, the processes are quite different. A molding process uses pressure and heat to fill the cavity of a mold, a rigid frame also known as a matrix. The raw material, typically a pliable one like plastic, glass, or ceramic, is kept under pressure until it solidifies or vulcanizes. There are 4 types of molding processes, application and advantages. First is compression molding. The compression molding process is used to make rubber and plastic parts. In the rubber compression molding process, preformed section of rubber is placed in a heated mold. Then the mold is closed and held under pressure until the rubber takes the shape of the cavity and vulcanizes. The second one is melt molding. Melt molding, when applied to thermoplastic materials, and compression molding is referred to as melt molding. For this fabrication technique, the polymers are heated above their melting point, so they can assume a liquid form. The third one is transfer molding. In the process of transfer molding, the chamber prior to being forced into the mold, the chamber may be in the molding machine or in the mold itself. And the last one is injection molding. The injection molding process can be used with both thermoplastic materials and thermosets. Injection molding machines inject molten polymer materials under high pressures and speeds into closed molds. So, creating these molds can be more expensive. The process can ultimately provide finished parts and high production rate. There are this picture that shown the types of molding. Compression molding